Hey everyone, and welcome to the Synapsewerx engineering channel. Today we have yet another fantastic product demo for you. As you know, at Synapsewerx, we're big believers in the transition to real-time operational data. Organizations have traditionally operated in a batch data integration mode, which is kind of okay for traditional data warehouses and retrospective data analytics. However, the more modern and contemporary business operates in real time with access to real-time operational data, real-time golden data sets, and real-time operational decision-making. We believe that access to real-time data is fundamental for any AI agents embedded within an agentic workflow, and we believe that this is the future. So today I'm extremely excited to be talking with Bhargav, the practice director for data and streaming here at Synapsewerx. Now this week at the Melbourne Apache Flink meetup, Bhargav presented a solution architecture and an accompanying demo to showcase how you can use an LLM with Flink via an MCP server to enact real-time data processing. Now, excuse the pun, but all of this was within the blink of an eye in less than 400 milliseconds and in stream. Now, when you think about the implications of this use case, it's pretty phenomenal and has the potential to be a game changer in dynamic data integration. Perhaps this is even a new design pattern. I think, time will tell. Anyway, for those of you that couldn't make the meetup in Melbourne this week, we thought we'd ask Bhargav to record the demo session so that you too can enjoy this fantastic solution design. Now, today I'm also joined by Carlos, our CTO and Chief Architect, and together we're mostly going to listen in carefully as Bhargav takes us through his innovative demo. But before we do start the demo, Carlos, can you perhaps just give us a bit of context around MCP, please? What is it? How does it work? And what's the relationship between the LLM and the MCP server?
Yes, absolutely, Malcolm. And this is a very good question because that is something that came in the meetup. A lot of people think that AI equals LLM and MCP is just a variation of LLM. These concepts are really not that clear as we thought, and so it is very important to make a pause, and think about what is AI, what is LLM, and what is MCP. So, and this is something we have been talking a lot in recent videos, and we are going to keep talking in future videos for sure. But every time that we are talking about AI, it doesn't necessarily mean an LLM. An LLM, obviously, it has with this a concept of reasoning that we are using in order to create agentic workflows. And when we are allowing an LLM to reason about certain aspects of a task, then it needs something. We are going to equip an LLM or an agent with tools and resources that ultimately make the actual task. This is where MCP comes into place. MCP Server, in this case, and Bhargav is going to use many of them, different types of MCP servers. They understand the protocol between an application and an AI agent that ultimately is going to be using these resources and tools in order to make the right task, that is going to ultimately complete the objectives of tasks that we are meant to do. One interesting thing, Malcolm, as well, is that, what we are going to see today with Bhargav is, as you mentioned very accurately, Malcolm, it is a glimpse of the future because it is not a traditional chatbot that is led by a human prompting something and then getting something back. However sophisticated this could be, it is not what you are going to see. What you are going to see is an evolution of this thinking. We are still going to be using LLMs for sure. We are still going to be using MCP servers in order to get access to resources and tools in the background for sure. But there is not going to be any chatbot at all. However, there's still prompts, and Bhargav is going to take us through how is that these prompts are being utilized in a very considered way, where there are business rules that ultimately are following the behavior of data in motion, data on a stream with Flink, and ultimately based on all of these different messages and events, different actions are going to be taken into place, and these actions ultimately will create these prompts that then let an LLM to reason about what tools need to be used. So it is very phenomenal demo. It is not a traditional demo that you see every day on internet. It gives us that access of autonomous or autonomy and agentic autonomy, which is truly fascinating. So without any further ado, then I'll just pass it on to you, Bhargav, and looking forward to learn about this demo.
Yeah, Bhargav, welcome to the channel, mate. It's good to have you here. And look, I've heard there's a huge amount of buzz around this particular demo from last week. Carlos, what you just said there, like, it just gets me giddy with excitement. There is no chatbot, but the LLM is interacting with really structured data in a really considered way, with guardrails, with a rules-based mechanism, and all of this is contributing to an increased level of accuracy. And look, no humans in the loop in this example, so it is quite a phenomenal solution. And hey, Bhargav, I don't want to steal too much thunder, so over to you, mate.
Cheers. Thanks, Mark. Thanks, Carlos. Hey, good day, everyone. Today we would be, as Carlos and Mark mentioned, we'll be discussing a Flink Kafka plus real-time event stream processing using generative AI and MCP servers. So the term may look like too many components to get involved, but in reality, it's pretty simple as as we discussed down the line. Yeah. So let's quickly jump in. Probably I'll go through that. Some of the key concepts, what exactly these are, how exactly it helps to drive the business, and do a real-time decision making, and solve the business problems. Yeah. So as most of you are aware of it, the Flink is a real-time event processing engine, which predominantly read the events in real time and process them, and then either store it in some other area, or to write your custom code, inject your custom code to take an action with regards to that, right? So, and also Flink can support a batch processing, but not in this demo. We're not going to talk anything much about the batch processing, but let's focus on that, the event processing. So any of these event-driven applications can be hooked to this Flink process. So where do we get a big advantage using the Flink is it's a distributed data processing engine or event processing engine. What it means is that if you have a parallel stream of data which is coming through, you can hook to that the Flink, and Flink will process every event in real time in parallel, so that you won't accumulate any lag, or the events doesn't need to be stacked up one another one. Also, Flink has this nice feature called complex event processing, which predominantly will be touch base with the event processing engine. But the complex event processing is basically it keeps that the context of previous events, and the taken action based on those particular events. And the other feature you get it from the Flink is the machine learning and AI capability. So if you have a trained model, you can pass to that model, and it has a Lambda function, it can execute it and give the output back to you as in parallel, right? So these are all the main key functionalities of the Flink, and let's jump quick to that LLMs, right? The LLMs, most of us, we know it, generally we all use ChatGPT or Gemini or any other LLM. Right now they're in the market. Basically, these are the models which trained on text processing, the natural language processing. That includes that they've been trained on huge amount of text, and it can generate ample of output whenever the question what you have asked And it's mostly used as a question and answer scenarios. These all the LLMs as of today, and they are conversational agents. So you can initiate a conversation and keeps track of that, the conversation keep going. How it keeps track of it is, there's two concepts here. One is the context, other one is the question, as simple as that. So you give a context to the LLM and you ask a question. Based on the context, the data which it get trained in the past, it provides a rightful solution to you. As simple as that one, nothing more fancy, nothing more special. Just ask a question, it gives you a response based on the context what you are, right? The best possible context it gives you, whichever is available, based on that, the accuracy of the information what you provided, and the right question what you ask, you get a response back, right? So people use this as a prompt engineering, or perhaps like the other ChatGPT applications kind of a thing. You write an email and you say that correct the spellings and grammar. It does know that what exactly you are writing it, and it reads you and recorrect them basically, right? As simple as that example. Right, we are not focusing much on that, the image generation, video generation, and all those capabilities right now in this demo, but it's just a simple text processing. So some models are very good at generating the general text. That is what we use it. Some models are really best at generating the code, and some models are best at generating the images and all other aspects. So in this demo, what we're going to use is we're going to use the Google's Gemini model 2.2 Flash, basically, which gives you that the simple context. We pass in a context, ask a question, you get a response back. As simple as that. But why? Okay, so let's jump into the next slide before we go down on that, the nitty-gritty things of that, what exactly the demo, how exactly been performed. We stick back to that schedule, which basically explaining each of the components, what we're going to use it, and how exactly it's going to be performed. So the next one is a model context protocol, right? So MCP, right? So previously, as we discussed, the LLMs are good at providing a response back to you for a question what you have asked, right? But they are not capable of executing a code or doing an action for you in behalf of that, the question what you ask. So what we're going to do is we're going to use a technology called MCP here, which basically will generate context information for the tools and technologies what it has it, and then give it to LLM. The LLM can say that, yeah, fine, this tool has these kind of capabilities. I can generate this input for this particular tool, right? So that's what we're going to do it integrating. So one step back from there is basically MCP servers are very simple concept that whenever you write your integration application for the app what you are building, you don't need to write 1,000 different ways for 1,000 different applications. For instance, Kafka uses that SAML protocol, SASL protocol, or Slack may use a REST token-based protocol, or MySQL uses a JDBC protocol, and HTTP uses a REST protocol, right? So you don't need to write all of these different protocols every time when you do it, or different client libraries you need to incorporate on your application. Rather, what you do it is you build a centralized servers, basically MCP servers you call it. What they does is it holds your credentials, authentication mechanism, client libraries, pretty much everything, and it gives a seamless interface to MCP client. The MCP client is as simple as that. Basically, you fire up a tool call. Basically, hey, I want to use this tool. Here is the payload. As simple as that, similar to how you give your Swagger specs or maybe a database DDL statements or query text standard, right? It's a standardized format for these MCP client, which basically we're going to use it as LLM interaction there, right? So this is a centralized piece, and these MCP servers are thin, and they does only one thing what is being coded inside it. So for instance, if I code a couple of things for a Kafka, such as that create a topic or list the topics in my Kafka servers, brokers, or maybe perhaps I say that write a message into this Kafka topic, right? So that exact thing, it does perform it. And basically, whenever you give that particular request, you would be saying that, hey, here is the topic information. Here is the tool call. What I'm making is a write into topic tool call. You code it inside the MCP server, and that eventually be action be performed. For instance, Slack, you say that send a Slack message to so-and-so channel, right? So whenever you ask that one, basically you will be writing the code underneath that one in the MCP server saying that what exactly the call, we have to make it to the Slack API, and all the credentials and everything get encoded in this Slack MCP server for the Slack, right? Same goes with the MySQL. It uses the JDBC behind the scenes, or like ODBC, whichever it is being coded in that, and then eventually that will interact with MySQL Server. All right. So this is tools, basically the collection of tools, what you are making it on your toolbox. And you always interact with one kind of protocol here for any tool with regards to whatever it is. Is it a Kafka? Is it a Slack? Is it MySQL? Is it HTTP? You don't care. You always use MCP protocol to interact with it. So what exactly this means is, like, this is a simple picture I got it from internet, that if you don't use the MCP server in general, how do you make an integration as of today with your application is, you would be making your AI application to interact with each of the service what we have, right? You got to write a specific APIs, individual APIs, and then make they get exposed to the AI application, right? So the code is all over the place now, right? So what we do is we just decentralize them, saying that, okay, fine, you have your local specific implementation for MCP server. So which basically that, the JDBC will have a JDBC implementation with that, and Kafka will have a Kafka implementation for that. And they both will provide a single seamless interface for your MCP client. So what it means is that, you have a single interface, like it's the same specs, you're going to use it, the tool call, and basically what tool you're going to use it, what are the parameters it takes. As simple as that, right? That eventually MCP server convert that as Kafka request, or maybe like, database request or a REST request.
And sorry to interrupt, Bhargav, but I think just at this point, given some of the questions on the day when you presented, it's just worth pointing out that the MCP server is not the LLM. It's not the LLM isn't interacting directly with the web services or the database or the local files.
Yes.
That's all about the protocol within MCP, and it's using those protocols, which is all very deterministic.
Yes.
The how you interact, i.e., what the client is that interacts with the MCP server. That's where the AI application or the AI agent or the LLM starts to come into play, and that then it's only the LLM again interacting using MCP protocols that interacts with the MCP server. Is my understanding correct? Is that right?
Yes, that's absolutely right, Mark. That the LLM will generate the protocol information, like what exactly that the request has to be made to the MCP servers, and that request we're going to take it and we're going to pass on it to MCP server using the MCP client what we're building it on this application, right? So we're going to use the MCP's SDK, which is a standard MCP SDK, which you get it, which has been used Java SDK as in this application. And to interact with LLMs, we're going to, as I said previously, we can use the Gemini 2.0 Flash, and for that, I'm going to use the Gemini AI SDK, the client, software client from the Java side. Yeah. So it's a simple Java application. It's not a big code. It's a very, very simple code. The main idea or the concept behind this demo is that let's not write thousands and thousands of lines of code and manage it. Rather, you give this application to that end user and let the end user, the business user, like the product owner or perhaps a business analyst, will write this logic by just in normal textual terms that eventually we convert as a logic and get executed in real time. Right.
And again, sorry to interrupt, but a key business point that you're making here is, and some of the reasoning and the benefits behind this architectural design pattern and approach is that without MCP, we have to code all of that. And this is what we've been doing for years and years and years. This is what integration's been about for the last 30 years, how we connect one application to another application and interact with data and extract data. And that's all coded, and we need highly skilled engineers to do that. Versus this proposed approach using MCP and LLMs, where it becomes a lot more dynamic, and it's interacting with data on the fly in a dynamic way and method, and you don't need to code that because the protocol of MCP is handling all of that.
Yeah, exactly, Mark. Exactly. That's right.
So that means from a business point of view, potentially we can access data quicker, faster, and more cost effectively and it starts to democratize the access to that data as well.
Yes, exactly. That's the case. And also, the best part of this is it's scalable in terms of like today you have three MCP servers. Tomorrow you want to integrate some other system. Basically, you build up a new MCP server, add to the MCP server pool, and then you have every call, whatever you coded inside the MCP server is available to your agents or your real-time the operators, whoever is there to interact with that system.
Very cool. Thanks, Bhargav.
Yeah, so let's quickly jump into that, the business context, like, for the demonstration purpose, what exactly we're going to do it in the demo. So try to mimic that, the real world scenario that, which make kind of like, people familiar with that, how exactly the business process works, because pretty much we are all across that, how the e-commerce works. So basically you go to that, the Amazon or eBay and you just place an order. And eventually the order will be fulfilled by checking that, the stock in warehouse, and, warehouse will prepare a pack, and eventually that being collected by the postal service, and then get delivered to you, right? So this is what the general e-commerce, any e-commerce in the world usually performs that, right? So what we're going to do is let the business process continue as is what's happening now. We're going to tap into multiple locations. So if, let's say that you don't have enough stock in the warehouse, right? What you want to do is you want to notify the warehouse saying that, hey, you are running out of stock, please restock it because the new orders are coming to pick it up. And also inform the customer when the stock is available, you're going to deliver that particular item, right? That's one example. Usually you do it. And the second one is, let's say your order gets successful, and then you want to write into a database saying that, all the orders, what you received it, so that you can use it, or a data like perhaps you can use it, in aggregated analytics down the line, later point in time, if you want to do so. So that's another use case. Like basically what you're doing is your real-time system is interacting with your data lakes behind the scenes, and without needing of any of the engineers are building up these pipelines and, batch processing or like streaming pipelines to do all these things, right? That is one thing. And the third thing is perhaps like, you have another postal system that, your order is ready, everything is get packaged, ready to be picked from the warehouse. And you notify your postal service saying that, hey, here is the order ID, which I have it, or here is the package ID, you please pick it up from this postal service using a REST call, and then postal service guy will come and pick that up, right? So these are the general things. We're going to code it here, and basically we're going to demo that exact thing, whatever I said it. Not over exaggerating, but it's a very simple thing to achieve it over here, right? Moreover, all these rules are dynamic rules. What it means is that today I have one, tomorrow I want to change it a little bit, saying that, okay, fine, I also want to do something XYZ while your business process is running in time, then you can go and update these particular rules. That's where that, the Flink comes very handy, that, you use this broadcast processing, which basically your rules get cached, and then, everything, whenever it get matched, then it will continue to do course of action, right? So the Flink here is an engine or a framework, you call it, which get everything railed over there. And the rest of these MCP servers are like, perhaps your Gemini LLMs and all those things are like, the pieces what you're going to build them together. So think like, it's a Lego blocks where stacking one after another, and then eventually you complete your business flow. And that business flow is fluidly changeable. Like, you can change it the way you want it, and you can achieve it whatever you want it without needing to write endless SQLs or endless, maybe perhaps REST calls or whatever it is, the client calls, what you're going to make it. Yeah, using the help of MCP here.
And just Bhargav, just before you run the demo, just one very interesting point that I find fascinating is that this was always the promise of the modern event-driven architectures. To change from very rigid and hardwired orchestrations into flexible choreography of events that ultimately there were going to be potentially multiple subscribers to those events, and they were going to be adding a capability, business outcomes based on those events. What we are doing now is even going beyond that point, where we are not necessarily even taking any of these events out of the stream to us as subscribers to be consumed for specific business purposes. What you are suggesting here is that within the stream itself, there will be this logic that you are just going to describe that ultimately is identifying these patterns. And when that happens, then also in a very, very open-ended way, it is going to interact with the MCP servers in order to achieve the goals that are meant from an end-to-end business point of view. I find this truly fascinating.
Yeah, certainly, Carlos. That's the case. Yes. Now let's jump back into that. Whatever we discussed on e-commerce, how exactly it fits in the technology landscape. That where exactly we can tap in these kind of LLMs and MCP servers, and basically the Flink, Kafka, whatever it is. We discussed more of these things. The first thing is that as we said, your events are coming through. So Flink is great, as most of us are across that. Flink is great at doing this, joining 2-3 streams and then getting a full context of it. Let's say you place an order, you join with that inventory from the inventory store, inventory stream, and then basically you get that how much stock you have in each warehouse for these particular items. The Flink is great at that. We're not going to discuss on this one because that's a fundamental basic thing, but everybody does it. Now what we're going to do is, we're going to take these rules, the business logic from the end users. Like basically the end user can code this rule either to send to a Kafka topic by a web UI, or basically he can use a simple MCP client such as Cloud Desktop or something. He can pump these rules into the Kafka topic, and that eventually resides inside the Flink engine. All the rules what we coded, because obviously rules are handful always, right? So think that why we pick the rule engine in first place is that if you consider any business process, regardless whatsoever it is, it's all the rules and actions. You have a rule. If you perform that, if you fits to that rule, do a course of action. That's what that entire IT systems runs, right? So, and then if again, you repeat the whole process till you complete your workflow, right? So what we try to do here is that the course of action, what needs to be done, we offload it to MCP servers. To matching up the rules is being given to the LLMs. Right. Also, we use LLMs to generate that the compatible payload for MCP servers by LLM. Yeah. So probably I may be multiple times mentioning LLMs, MCP, LLM, MCP, but it's what the reality is that we're going to use extensively these two technologies right now, and then we use we rail them all this on the Flink using the Kafka event processing. Yeah. So the incoming rules will come. Basically, I code something saying that, hey, my stock levels are like, order is not fulfilled because of that, partial fulfillment of the stock. Then probably I code that as a rule, right? And then input event comes. What Flink does is basically you pick the rule, you pick the event, send them to LLM. So as we discussed in the past, LLMs are great at provided you give a context, you ask a question, it gives you a response back, right? So as simple as that. So we exactly use for the same fundamental concept, such as that you give that input event which gives you the context, you ask the question which is basically the rule, you give it to LLM saying that, hey, whether it's matching or not. The simple question we're going to ask it, and LLM will tell you that thumbs up or down. Basically that's it. We are interested in only getting those two things, right? If it is thumbs up, which means that the rule is matched, then do a next course of action, right? And if it is not, perhaps you're going to do it is saying that, yeah, you're not interested in this particular event, just move on, continue to do the next thing what you're doing it, right? So now first case, let's say that thumbs up, which means the rule is matched. Once the rule is matched, then what you have to do is you will ask a action to be performed, right? The action can be writing into a database or data lake, or perhaps like making a REST call or making a Slack call or making another API call, right? So that's an action, right? To make an action, the first what you need to do is you need to know what are the tools and technologies available on your toolbox. Such as that, you're going to query all the MCP server list, what we have it. The MCP servers also has this nice feature called expose their metadata. So which means that what they say is what and all the calls they supported it, and for what is the schema, which is basically the parameters needed to make that call. For instance, if you want to list topics in Kafka, so usually what you give it is a perhaps if you want to write a message to a topic, it will tell you that, basically the payload and the Kafka topic, you give it, right? And the message will go there, and provided you give that information, it will write, MCP server will write the data into the Kafka topic, right? So similarly, what we do is we query all the MCP servers and give that latest metadata what you are after for everything what we have it, right? And now you have all the tool set what you have it right now, and you have an action what to be performed. We again go back to the LLM and ask it saying that, hey, provided you given with all these tools, I want to perform this action, give a payload to perform that action. As simple as that. So we are only limiting the LLM to get to know that what exactly the boundaries. You define the predefined boundaries saying that, hey, don't overthink it or don't hallucinate it or don't do anything. Basically, provided these tools you have it, here is the request, how do you do it? As simple as that, right? And also we are saying that, provided this output as in strictly compatible manner of that, what these tools accept, right? So then you would get that action. So basically, if that action comes back saying that, hey, here is a tool call, you make it, and here is the payload, the same payload will pass on it to the MCP server, exact MCP server, what it is, right? So for instance, if it is a Slack notification, as in this example, we're going to do it, it sends a Slack message or MySQL write, create a table or insert a data into a table, something like that. It can be a data lake as well. Like, it's an iceberg, it's a delta lake, it can be anything, right? Perhaps it's a custom action, like, you have a custom MCP server, you wanna write it like a REST call or something like that. We're going to show the REST call and in this demo, and then perform the REST call and then continue that event. So what we can do to have more rigid or like kind of like guardrails around this is, whenever you make these actions, you can write these outcomes into a topic saying that if it is outcome is successful, you write into a successful event topic. If it is a fail, you can write into erroneous topic, so that we can refine this questionnaire, the questions what we ask to the LLM, much more rigid way, so that you will have zero fallouts on this whole process. Yeah.
I think right there, some really key messaging, right? So I think what you're proposing, and why I get super excited about this use case and this solution architecture is, some of the challenges that we face with LLMs, you're really addressing here in this solution design, Bhargav, by introducing the concept of rules, and then making the LLM comply with those rules and make decisions based upon those rules. But also then introducing mechanisms that we've had traditionally within integration for integration frameworks and designs for a long time around alert notification and error handling almost. It's like, so when something doesn't comply, when it's not working, it's getting posted to the correct topic, which allows us then to be able to look at that, make decisions, and investigate. So this is really exciting, because what does it all mean? I think it all means that we're starting to put constraints in and put control mechanisms in place that really starts to improve the accuracy of GenAI in real world operational solutions. And this is really fundamental at the moment. This is a bit of a game changer in my mind.
Yeah, that's certainly true, Mark. Let's quickly jump into the payloads, what we have discussed. We stick back to that, the order management process, like the e-commerce order. For instance, I have a customer who placed it. It's a sample payload. I again asked the LLM to give me a sample payload to do so and so. So it gave me nicely this particular one. It's a mock payload. Simply, this customer is placed, but it said that the message is order placed successfully. The inventory allocation is in progress, which means that it's not fulfilled properly. So if you see that he or she basically ordered one headphone and basically 2 USB chargers, right? And then, as we know that the Flink can real-time fetch this information from the warehouse for each of these items, products, and assuming that it's already did this work, and it gets the inventory information saying that inventory status is partial allocation, because obviously the headphones are available, because basically 35 headphones are available in stock, and the user is requested one. That's fine, all good, no problem. But when it comes to the USB chargers, the only one charger is available, right? And so basically this caused that the stock to be partially allocated, and it basically have warehouse ID and similar things. How do you code this rule? the coding this rule is very simple. That basically what you would do is, if your inventory status is partial allocation, and if your order is successful, which means order placing is successful, status is successfully placed, then immediately you need to notify the warehouse team, right? So what we do is we simply code like saying that if inventory status is matched with the partial allocation, what you want to do is send a Slack notification. As in this example, it can be a REST call as well, right? For this demo, what we are doing is send a Slack message to that MCP Flink meetup channel with the following message with inventory shortage, for what inventory it is, in which warehouse it is, for which order it's happening, and what are the customer details you need to be fulfilled when you get the event. So this message is like basically will go as is into the Slack channel with all the filled in information that what exactly coming from the payload. So I'm not gonna write any JSON marshalling, unmarshalling, or getting these objects, or creating any POJOs, all those things. I'm not gonna do any one of them, right? Or rather, I ask that saying that, hey, fill these details and give me these details from LLM, and LLM does this for me. Yeah, as simple as that.
And Bhargav, sorry to interrupt you. I promise not to do it too often and just let you go through the flow. But you just mentioned here something that I find pretty important to highlight to the viewers, and that is that when we talk about agentic AI, and when we are talking about the future of integration, this is exactly what we are referring to. In the same way how we are, and we have in the past exchanged XMLs or JSONs inputs and outputs, that is going to remain. We are still going to be exchanging JSONs and XMLs and different types of formats, but also one new way of communication in agentic AI workflows is exchanging prompts. And this is the importance of prompt engineering. This is important of now understanding prompts as code, and ultimately following all the best practices we have learned in the last decades about how to treat them properly. Because ultimately, that action value that you are presenting here will ultimately become an input that ultimately will evolve into an actual code. Like it could be SQL, it could be Java, it could be Python, it could be a REST input, it could be whatever it is that ultimately is going to be executed by the MCP server to the backend resource. And this is something that I just wanted to highlight, that we are going to start seeing this blended approach of sharing inputs and outputs, where there are going to be, yes, the standard XMLs and JSONs, but also it's going to be prompts, which is exactly what you are mentioning here.
Yeah, that's absolutely right, Carlos. It become like more fluid, I would call it, or like more loosely coupled. That the inputs and outputs, as in like it's continuously evolving. The end user itself is be able to make these changes on their side, right? And also the best part is that you don't involve multiple systems in between, so that the things will break just because of these compatibility issues with the schemas and all are reduced now, because you're straight away talking only two systems, your MCP servers and your LLMs, right? The error rate is also will drastically reduce it, rather than piling up one system on top of other things. And
and it's the combination then of that structured data JSON that we're used to with those prompts that really enables what I guess I refer to as that dynamic integration. It's it's because of the flexible nature of the prompting that we get that dynamic on the fly change. So we're still communicating using structured data. That's still going backwards and forwards, but we're doing that in the context of the prompt. And it's that prompt that gives us that dynamic nature, which is super exciting.
Yeah, absolutely, Mark. That's absolutely right. The structure will be being governed by your MCP servers now. The MCP servers, whenever you code it, you're going to say it like, the client server will only accept in this format. And that's been exposed to LLM. And you ask a general question saying that, hey, here is the context, fill in the details, all it's needed by the MCP server. The LLM will fill that exact information what we asked to fill it in and give you back the payload for the MCP server. And that eventually we send it to the client application behind the scenes. right? So now the other one is ready to ship event, which means that order is ready, order is placed, paid, everything pretty much. And you have your stock and everything is there, so no problem. The inventory is also fulfilled and the package is ready to be shipped. So your status is ready to be shipped. And then basically you want to write a rule saying that okay, fine, I have this. If order status is ready to ship and inventory status is fulfilled, you don't need to be right as in like a programming equal to and all those things, right? You can ask anything in general text because obviously this information gets sent to the LLM server. And so I want to write a short code. That's why probably I put it. But if you say that, if order status is matching to ready to ship, you can write it. That obviously that does match it as well. So you don't need to be like, strictly bound by that, the terms or whatever it is. Yeah. And then what we want to say is we're going to send an API request to this particular endpoint with the body as a JSON format. Is saying that, basically from an input event, you pick up these values and send it to the MCP server.
And Bhargav, just a quick note for any organization that is watching that they are still wondering whether it is a good idea or not to comply with the schemas in Kafka, then this is yet another reason why if you invest a little bit of your time trying to ensure that those messages that are in Kafka are complying with schemas, then it will give you this level of sophistication in which you can simply just use those fields that are inside those events in the stream, and you can combine them with rules, you can combine them with prompts, and they will ultimately be very, very powerful way to ensure that you are pointing to the right data to and get it and use it in order to get the next best action.
Yeah, certainly, Carlos, that's true. And the next one is basically your order get placed, order completed successfully. Basically, your order status is successful and inventory status is fulfilled. If this is there, then what we are doing is we want to write into data like this particular event. So simply I use that as MySQL here. In this particular case, I say that execute SQL, write this record into completed orders. If the completed orders is not existed in the database, create one and eventually insert the data with these particular fields as this information, right? As I said, so what LLM does is basically it create DDL statement and eventually write an insert statement to that one, right? And without even failing that, in case if the table is not existed. But if you want really want that to be fixed, that, you can remove that, DDL part and simply write into this information, and then LLM can pick it up and write an insert statement strike, and it gives you back, and then you can make a tool call to that MCP server, and MCP will write that record for you, right? As simple as that. And yeah, let's quickly jump onto this demo. So you can run the demo in two ways. Number one is basically you can run it as in that, the test suite here. That's number one. So that, I want to interactively show this information. But also I make the same demo, exact demo with the containers. Basically you run it as a Docker compose environment that bring up the Flink application, Flink server, and your database server, your Kafka server, everything will come in there to that, right? Eventually, all the tools and technologies comes as a Docker container. In any machine, you can run it, and eventually it'll run as an application. But now, for demo purpose, I'm going to run it as normally, like, basically as in a test mode, and let's see how does it run. I simply run my test. Basically, it'll have like, I'm going to pass on a couple of events to Kafka, and that eventually be consumed by Flink, and then the whole workflow get triggered to that one. Yeah. So it's being started. It's loading that, basically rules and, actions and pretty much everything, your input events as in a JSON messages. So simple SQLs, as we know that, in Flink, you can code it as an SQL, Python, Java, Scala, whatever the programming language you are interested in, you could write it. So simple thing, load from Kafka and load from database, all this stuff. There's nothing is there at this time other than the topics and other information. So we're going to see that, simply by posting one event. So either you can post it using that, the Cloud A desktop, or you can do that, same posting by using the your CLI, Kafka CLI. Or generally in a business enterprise applications, all your e-commerce application or any other application directly have an interaction with the Kafka servers behind the scenes. right? You can tap into the same topics what it is writing that, right? So for this, for initially, I'm going to use that, the cloud desktop to pass one event. So basically, let's say you have this order placed event. Let's assume that the case, right? We didn't put any rules at this moment yet into the system. So what I'm going to write is I'm going to ask my cloud desktop to post this event. Write the following message into event topic in JSON format. As simple as that, you ask to that, right?
You have a typo in topic.
Oh, did I?
Maybe it will still figure it out, but just
Topic. Yeah, it will figure it out. That's what the LLMs are doing, Carlos. Okay, so into event topic, I just mentioned in a JSON format. I simply gave this particular payload, and I said that no, fine. I'm just gonna do. Yeah, I just write it here. Let's see. So I'll help you to publish to the JSON message. So it's basically what it says. So it's asking that, what exactly that, the topic name it need to publish. So I'm saying that, the event. So right into the event topic. So it's basically, so you could see that, this is what the tool call, what I mean by that is basically the MCP server needs a topic name and message value, right, to produce it. So that eventually produce that to event topic. So you could see that, it's written on the offset 0. And it's for this particular customer, the data is gone in, right? So since we are running the application behind the scenes, you could see now that message is automatically being picked by your this one, your Flink application, as we do it on the other application. That's basically your e-commerce application or any other application. There is no matched rule detected for this event. That's straightforward. It came, right? So I just put it as a print message so that we could see and do that for a demo purpose, right? Now let's do one small thing, simple things like, let's jump onto the demo one, right? So the demo one is fairly simple that, let's go and first pick up that, the pending stock event, and we're going to write the pending stock rule together and see that what exactly it does, right? So let me quickly jump in there. So if you see this one, it's as simple as is that, basically the pending stock rule. I'm going to publish to that, the rule topic. You could see it here, and followed by I'm sending that, pending stock event, sending to that, pending stock topic. Sorry, the event topic, right? So when I hit this one, I think I'm in the wrong directory. Excuse me for that. Just run this one, yeah. So when I run this one, these messages will eventually go to the Kafka, and that's been picked up by the Flink engine, and you could see them here saying that, basically the rule matched. So whenever this rule matched, basically notify the warehouse with on partial allocation. This is what the rule we configured it as I showed in the past, and that rule we said it is basically send a Slack message to the warehouse, right? So you could see that the Slack message is perfectly being coded. Basically, it went to the Slack end API endpoint, and it interacted with the Slack and everything. So let's see that whether it came to the Slack or not. So if you see here today at 12:48 right now, you see that inventory shortage for this warehouse for order so and so, shipping address is so and so, customer details are this one, and yeah, that's it. So you get to the Slack. So if you see this example, I didn't code anything for this Slack, absolutely zero code. But of course, the MCP server did it. What I asked is, hey, here is a payload. If it is matches this one, send a Slack message. In general terms, I asked it, like in a natural language, I asked them. So it eventually did it, right? At the end of the day, I didn't write a Slack API in my code, right? So it's a reusability, as I mentioned, as you mentioned, Carlos, in the past, that the amount of code what we produced is completely be refactored, and it can be centralized code, can be used by everybody.
Yeah, that's right. And Malcolm, and that you can see why most enterprise vendors, like IT vendors, are rushing to build their own MCP servers and make them available, because this is the new API that ultimately is going to provide this bridge for development communities to create new capability, new application, new services that ultimately will integrate into each one of them. This is now truly important for everybody.
This is the new dynamic window into every application that's out there. This is the new feature that allows us to interact with, to query, to extract data, to insert data into our applications in, as I call it, that dynamic way. Doing it, this is dynamic integration and dynamic interaction. And I think this is a game changer. I understand why every application out there is going to rush to implement this. And I understand what that means for us in the integration, data and AI space. I think this is the new frontier, right? And I think we all need to skill up in this. I think this is so cool. And it gives access to data. It gives access to integration to a whole new group of individuals, right? I think for a long time we've been talking about how we take these skills from just highly skilled integration engineers and bring it into a business context. Lots of organizations have tried it over the years. I think MCP is the answer.
So just one step back, that we said that the payload for the MCP servers is being built by LLMs, right? This is what we told multiple times. But what exactly it means is that for the action call, what we make it, we ask the LLM server saying that, hey, provided here is the payload, make me a MCP server call, and provided I have these tools. I didn't say that, basically use the Slack tool or Slack post message or anything. I just said, as in my rule, saying that whenever this inventory is low, you basically send a Slack notification to this. I didn't give a tool call name or what tool you have it. None of that information I passed it. But what I exposed is all the MCP server metadata to LLM. I exposed it, saying that, hey, I have all these tools in my toolbox. You tell me that what exactly the tool I should make a call. And eventually, the LLM make this call, right? So, sorry, this is the one. So it said that, hey, provided the tools, what you have it, here is the tool you should use it, which basically send a Slack post message call. And the parameter what you need to give it is channel ID is a MCP Flink meetup is the channel, Slack channel. And here is the text you should, based on the thing what you asked for me. So it filled in that all the details what you eventually need to fill it in and then send it. That's it. And what you do is basically you take this payload and give it to MCP server. And MCP server do a course of action, right? What if it fails? Because your LLM did not do a right job, right? It's quite possible, right? It can happen. So what you can do it is, again, you take the payload, that, the response what the MCP given, and you give it back to the LLM saying that, hey, last time you gave me this one, I got this error. Now you please correct it. One more time, iteration. The LLM will see that, okay, last time I gave you this one, I got this error now, let me correct it. And it recorrect that and resend, give me the message, new payload back to us, right? And then we can keep repeating this loop till it gets succeeded. Or if you feel like that, it's over exaggerating these particular things, probably you can break in the loop, saying that, hey, try 3 times and eventually you give it up. Or you send this message to a dead letter queue so that somebody will take a course of action that why exactly the LLM is not generating the right input for MCP. That's where your guardrails are for your business, right? So now let's quickly jump into the next thing. Let's write a REST endpoint, this message. So your order is ready, everything is get packaged, warehouse, in warehouse, somebody, the postal guys has to come and pick it up. So simply I'll send a post notification message, right? So what I'm going to do is, here I have simple Makun REST endpoint. So basically I set up this, the pickup request, and I say that, so information come whenever it comes, you give a response saying that, pickup request succeeded, pickup ID, and simply this is a simple mock REST server, right? So I'm going to monitor the logs here, and my routes are already running on a simple thing. So basically I'll send this payload now to the Flink. Right, so that one is that's a ready to be shipped rule. I'm going to send to a ready to ship rule, and also followed by the ready to ship event, right? So I'm going to just send to the Kafka this event. So let's inspect the logs from the application side. Yeah. So now if you see here, you could see that rule match for notify the postal service on ready to ship. This is what the rule name what we get. It matched it because LLM said that it's matched with the payload. We are not writing any code to match any of these text in there. We are asking LLM to say that whether it's matched or not. LLM said that it's matched, and eventually LLM generated this payload request. So the tool call name basically with an endpoint details as API pickup request to the post and with the body as so and so information. So if you go to this particular Makun, you could see it in the logs. So the request came is that basically the order ID, order placed on pickup address, what pickup address it is, the customer details, customer email address, and number of items, and warehouse is involved. Everything came, and this information is being directly coded by this request is being generated by LLM. We said that we want to include all this information from your input payload, right? We didn't write any of the matching like payload matches or any of these things, or we didn't even in fact didn't write any kind of code to interact with the servers, right? So and then eventually the response what it get is presented back to that Flink engine saying that hey, response you got it is 200, okay, and pickup ID is so and so, and delivery schedule time for delivery is so and so. Because this is what that the rest of our endpoint we coded in here in the mock server roots. We gave it like the schedule time, some faker data, we just put it here. So the same information has gone in back, and it has gone to the Flink engine, and eventually that gets stored into the another topic. So your end-to-end business continuity being achieved here. There is nothing like a fallout or missing or anything in this whole flow, right? So now the one final thing we would do it is how to write a warehouse, data warehouse, or perhaps a data lake or whatever it is, right? Simply for this use case, I use that once the order get completed, we want to write into a database saying that for instance, if you see here, so order get fulfilled 100% and status is successful, everything is done. Just write the final record into database. So let's simply write this particular event into the Kafka. So you just write this to Kafka topic, and then once you go there, you could see again the log here saying that rule match for insert into blah blah blah. So basically, it create a table if not exist, and then write the record into the database. Right? You could see everything got completed here. And this is the database DDL creation statement, because obviously I included that, create a table if not existed. The table is not existed, so it created it one, and eventually it writes the followed by an insert statement, right? So this code is being generated by LLM based on the specs what you have in MCP server, and that eventually being ingested into the database, right? So two calls got executed, and then that's it. Done.
Bhargav, what I like of this approach is that not only you are using LLM for what it does well, but also you are doing it in a way that is following business rules, again, as we mentioned, but also you are leaving a breadcrumbs that can be used to identify the level of accuracy, to monitor constantly, even in real time, what LLMs are ultimately producing, and ensuring that if there is any issue, as you mentioned, well, there is going to be someone policing the accuracy of these LLMs to ensure that whatever is being produced, it is going to be correct, and then given out to the MCP servers to execute.
Yes, Carlos. So exactly, I want to emphasize on that thing, because this is the best example. You asked the right question at the right moment when that error occurred in this demo itself. That will show you that one. So when we say this insert into orders, the first call what it makes is it generated, it hallucinated, basically, and it generated a wrong SQL saying that create complete table if not exist, insert into this one. So it completely generated different kind of action, right? So whenever you gave this call, let me put it in another page and I'll show you. So if you gave this particular call to the this old call, sorry. So if you this one. So you see this one. So it generated an execute call and parameters are this one, right? So this is the code which gets generated. It is nowhere near to the standard SQL which the database accepts it. So it has sent to the MCP server. MCP server said that, execution error, saying that you have an error in SQL syntax, checks manually, manual that corresponding to MySQL syntax and write syntax. So this is the error which your MCP server gave you back. What we did it as in, this is in iteration 0. Then we feedback the same error to the LLM again, saying that, hey, you gave me a payload, I got an error, you give me that correct thing. Then basically what LLM this time generated is, this time it generated a proper message as in iteration 1, not as in iteration 0, right? So this is really fascinating thing that your errors itself been corrected by you, by the application itself, rather than you don't need any manual intervention. This time, it's properly generated create statement, DDL statement, because the error said that you have a syntax in error, the code which got generated, and eventually that get succeeded. You could see that, that eventually gets succeeded, and 2 records get temporary, error is null next time. So you can have a break this loop. So currently I included 3 as in for the demo purpose. So you can include 5 or 10, whatever it is. You may say that you don't want that one. Immediately you want to fail fast. You can go for that as well.
That is absolutely mind-blowing, Bhargav. One thing we have been saying a lot internally is that the same way how we have always in software engineering, traditional software engineering before AI, before this type of GenAI capabilities, we always design for failure because we knew it's not an if, it's a when. We knew that when things fail, then this is how we are going to know, and this is how we are going to recover. Exactly the same applies here. It's just that now you are also using AI to validate AI and to recover quickly and ensure that whatever you produce is exactly what it is meant to happen. We have a way to audit. We have a way to confirm. We have a way to move forward. And I think this is very fundamental for enterprise development, that we need to understand that AI is not perfect, nothing is perfect, nothing is going to provide accuracy, 100% accuracy. But it is all about how is that, if it is going to be 98% accurate, well, how is that we can identify and catch that remaining 2% and recover from there?
Yeah. And it's this level of sophistication and thought leadership in the marketplace today that I think is really relevant. There's lots of individuals out there playing with AI and GenAI and LLMs and getting all sorts of wondrous results and confusing results in some cases. But it's about putting in place structured, robust frameworks, mechanisms, and traditional design processes that allow us to manage this. These levels of frameworks and thought consideration when designing an AI-based solution. I think this is what differentiates those solutions that don't make it into production versus those that do. I think my other observation is, like, I keep saying my mind is blown, but the observation is this: traditionally we would require a integration engineer or a number of integration engineers to build out every single one of these scenarios. To do that, we would have to sit down with the business. We'd need to understand all the business rules. We'd need to understand the context of the business, the wider enterprise integration landscape. That would probably, for these types of scenarios, take weeks. We would need to document all of that. We'd need to then think about the design specs, build out technical design specs for every single type of scenario and interface. And then we'd have to get funding, right? Because all of this costs a lot of money. We would then go into development, probably an agile approach these days, and go through multiple iterations across multiple different products in order to get them then unit tested, system integration tested, UAT tested, performance tested before deploying them. All of this taking time, effort, cost, and money, and in the process experiencing lots of errors, fixing all of those errors. Right, you get the idea, a huge task. But with one simple design, with one single approach, we've got a combination of LLM, rules-based mechanisms, and MCP servers into all of these applications where it's doing this on the fly, even to the point at which when it finds errors, it's fixing them through iteration itself. This must be a fundamental shift from the approach that we've taken traditionally in integration to where we're going in the future. And this, to me, sounds like a bit of a new age for integration. It sounds like, we said it earlier, a more cost-effective approach to doing integration. Should engineers be worried, I guess, is the question. Should integration engineers be worried? They certainly need to reskill.
Well, Malcolm, that's actually a note that I put here, and I wanted to mention that because any integration engineer watching this video should be not worried, but they should pay attention, because this is the future of integration. Integration is changing, and there's nothing we can do about it. I have been doing integration for the last 20 years or more. And one of the hardest part of integration is transformations. It's converting one payload into another payload. Yeah. And Bhargav just showed us how that transformation just happened dynamically, as you said. I always thought that the best possible a way of automating transformation was by using a low-code, no-code tool that ultimately was going to be using AI to provide recommendations, as in how to convert X to B, A to B, or to do it for me, and then I was going to be looking at those arrows. Well, what if that is not even necessary? What if we don't even have to worry about these things? And what if we letting this dynamic integration work, and with this ability to know when things don't work, and we can recover from there. So I think you're absolutely right. My view is any integration engineer watching this should be paying attention, because this is the future of integration. And any organization watching this video should also pay attention, because what is going to happen, and it is happening already, is that this way of building dynamic integrations is building to that true speed of innovation and that true speed for differentiation. And that is going to start making a big separation between those companies that are able to move faster and they are able to differentiate. And they are just going to do one thing. They are going to force everybody to follow. So this is happening already. So the best we can do is to get on board and to start thinking how is that we can be prepared and use the best possible tools and capabilities that are available in the market to provide these organizations with that level of differentiation.
Agree. Very cool. Very exciting.
Malcolm, I just want to quickly close up very few things. It's internals of the Flink, where exactly we said that the whole thing is running on the Flink, but so far we talked mostly on that, the terms of like the LLMs and MCP, but actually the whole JVM or the code runs in the Flink engine, as in distributed pattern. I just want to be touch base with one slide, or perhaps maybe two. Here is the broadcast pattern, which is a very nice and neat pattern provided by the Flink. So what it holds is it keeps all the rules in the cache of the system, and your events can go in. But also, if you are, it's not just pertain to the rules, right? You can use even perhaps your two streams can be joined using this pattern, right? It's basically giving a context and asking a question to the LLM, right? So you can even say that whether these two are correlated or not, right? Based on these particular attributes of these messages, you can ask the question. Any question you can ask it, perhaps. So keeping that in mind, this is a broadcast pattern by the Flink. So what this does is, let's assume that the first one is that the e-commerce action what we discussed, and the second one is that the rules, second stream what we are getting it in. So every time when a new rule gets it in, that get copied across all the tasks, across all the task managers. So it keeps that one version of that particular data, which is basically the recent version of the data, and any event will basically eventually be distributed across multiple multiple task nodes, whichever is free. Flink will distribute them based on that the input keys and other things, and eventually that get matched. In the moment when you update the rule, the existing rule get replaced, saying that with a newer version, and then any new event which comes after that will eventually be qualified for that. What if I say that I'm not gonna use it for rules? Basically, I'm going to use it for a two-stream join, right? So one stream is having 1 billion records, and other stream is having 20 billion records. How does this broadcast pattern work? Because I don't want to keep all this memory, all this information in my JVM and get duplicated across multiple nodes, right? So Flink provides a nice alternate for that one. Is basically a keyed broadcast process function. So what this does is it distributes based on the key what you have chosen, and the same key you're going to use it for your events as well. So what it means is that the same records which matches the key will fall in the same JVM, and the remaining nodes will process the other workload. So your workload is evenly be distributed across all the inputs, and you can have the capacity of expanding further more based on that, the linearly expanding the capacity. What it means is that you add more hardware or more JVMs or more machines, eventually your processing capacity also be increased, right? And obviously this all be heavily tied up to that, the Kafka messaging system. You get the message processing guarantee, and then basically that the exactly what one's commitments, or at least one's commitment from the Kafka, and of course the distributed and speed from the Kafka is unmatchable, right? So, and if you go with the Confluent ecosystem, you get that stream governance, where you can messages and everything can be governed by this input schemas, and where you can't publish any kind of gibberish or anything into these messages, and eventually be everything get governed. And if it is not matching, you can send to that error bucket, or basically erroneous topic, which eventually get looked after, and then basically you remediate them back into that system. So the point I would like to make is that though you are using LLMs left and right and all, there is nothing to be no loose ends here. So everything is well governed using the traditional approach of basically having the rigid schemas and rigid process. At the same time, you're taking the help of that LLM to achieve that particular goal, right? So the point here is that basically the way that how we operate it is changing it, but the tools and technologies what we're going to use it will mostly remain be the same. Your Kafka clients will be the same, your REST clients will be the same, your Slack client or your database client or JDBs, everything is the same. But the processing capacity, the processing part, what we write the logic by using our brain, is been shifting towards that, the LLMs. And the interface specs or interfaces what we're going to build is shifting towards MCPs. Right. This is what the final statement I would like to make it on this.
Yeah, I think that is very good. And again, to me, it just proves once again that all that gained knowledge that we have achieved in the last few decades, it's still relevant. Everything is relevant, because this is basically the foundation on which we are going to meet the standards and the expectations of the enterprise needs, in order to be able to use different technologies in order to achieve better results. So everything we know is relevant, and but there are new things that are quickly evolving that we also need to learn.
I've overused the word today. So exciting, absolutely phenomenal stuff. I think what we're seeing here is a fundamental shift. I think a big change in how we've traditionally done integration. As I said right at the beginning, for me, and I know for most of us in Synapsewerx, real-time data, real-time processing, real-time inference is absolutely key to the future of where our organizations are going, where those enterprise architectures need to go. I think there is an intelligent transformation that's required to shift from the foundation that we have of our apps focus to to our LLM to AI and agentic workflows. And I think what Bhargav you've shown us here today is a big glimpse into the future. I say the future. I mean, you can do this right here, right now, and you can give it a go using that QR code and by having a chat with Bhargav. So look, super exciting times. Look, Bhargav, thank you so much for taking us through this use case. It's clear to me that there is a very real role for AI to play in the context of in-stream processing of operational data. It's also clear that what we're seeing here is an evolution in integration design pattern and methodology. Integration engineers and certainly contemporary organizations should pay close attention to the real-time, rules-based, dynamic integration approach that you've shown us today. I think it's the future. Having the ability to invoke a complex AI agent in real time using tools via MCP to query or enrich the data before it reaches its destination is simply mind-blowing and pretty phenomenal. Now, look, I hope that everyone that's still watching today's demo has got something of value out of what you've seen, out of some of the conversation and the commentary. If you want to know more about the presenters, if you want to know more about Bhargav, if you want to know more about Carlos, all the solutions that's been demonstrated today, then just please check out the description below and follow those links. They should give you everything that you need. Before we finish the session, as usual, I would like to thank you for spending this time with us today. If you've liked what you've seen, then please do us all a big favor and hit the like and subscribe buttons below. If you've got any questions for anyone in the chat today, then again, drop your questions and comments in the comments below. Thanks again, and until next time, keep having fun with meaningful technology. Thank you, everyone.
Thank you.
Yeah, cheers. Thanks, all.